However, aside from that, I need to explain exactly how to explain the basics for how I get rid of that gap that you saw on Lake Keveran. Well, to explain that, I need to explain how to go about calculating sizes and the such for real-world comparisons and the related. Well, you remember how that famous formula, pixels times scaling equals coordinate units, right? That's how Platform Masters gets all of its 3D effects, including the clouds. The clouds use 3,000 layers, which is why they're so pristine. The more layers you use, the better the 3D effects become. So, in order to determine just how the sizes and the such, I need to determine how many pixels it is. Well, in this case, it's, 112. And this is the scaling, 92. Okay? 112 times 92. That's what it is in coordinate units. But coordinate units, to almost everyone, doesn't really mean anything. So what is it in more real-world units? Okay, I'll convert it to feet. Divide 75 times 11. That's how you convert to feet. And that's what it is. But what about metrics? Okay, times .3048 to convert feet into meters. And that's what it is. A little less than a half a kilometer, 7/15 is a close one. And also 15/30 seconds is also pretty close. Yeah, I'm pretty good with fraction to decimal. After all, it's one of my shortcuts for getting more accurate estimates for multiplication of big numbers especially. So at least I can get an idea on what kind of value I'm expecting. It's just one of my shortcuts. But you now know how I calculate the span between there. And however, one thing to consider is, another Excel spreadsheet. And lots of numbers. This would otherwise be the kind of thing you'd see in my design document, except you can't do calculations in Word, at least as far as I'm aware. And with Excel, it's actually easier to look at things more at a glance, more quickly and easily. So, in order for me to get rid of that gap and the related, I need to use an indirect derivative of that formula to calculate, that pixels times scaling equals coordinate units. I need to use an indirect derivative of that. However, to understand what I need, for every, take this layer for example, just so you know what one that is. That's this here, these hills right here. Okay, hide those, put them back in so you know what ones. Okay, and then I'll do that. Okay, that's these right here. Okay, now for every, you know the foreground, right, where all the platforms are, the character, the jewels, and all that. That has a scaling of 1. That's the foreground. Now, these are background elements, so they're off in the distance. When you look at objects in the distance, and the further away they are, the slower they appear to be, and the smaller they are. It's basically almost like a ratio in a sense, but it's actually more complex than that. An arctangent is involved if you want to get more specific. However, for simplicity anyway, that's what 2D is kind of restricted to. What you do need to consider is, for every 48 pixels on the foreground part of the scenery, this part moves 1 pixel. This part moves a little bit more than that, 12/11 to be exact. Okay, now if this was to move 1 pixel, I'd be 44 coordinate units up. And this would move, 11/12 of a pixel. Essentially, it wouldn't move at all. Or at least not yet anyway. 4 more coordinate units up and then this, yes, will move. However, if you move 11 pixels on this particular layer, this will move 12 pixels. Remember, the lower the scaling, the closer the object is, and the more it actually moves. So this would be 12 and this would be 11. That's an offset of 1. Starting to see a pattern here or consistency? Okay. Well, let's consider this layer now. Okay, this is 60 and this has got 48. For every 48 pixels this moves, this will move 60. That's 12. Okay, but if you were to scale that down so that this was move 12, this would move 15. So it's basically 5 to 1 in a sense. Okay, 5 to the difference between this and this, which is 12. So it's 60 to 12. That's where that comes from. And that's one of the factors that's provided into here. That's part of it anyway. Now one thing that needs to be considered is the gap, the lowest possible low point in the hills. To explain that, we'll zoom in on these. I'll hide these. Now look, these are the high points. Okay, you can see where the high points are. These are a little lower. Now what I'm referring to by low points is here, for example, like this here. That's 15 pixels if you saw that. Probably couldn't. Let's see, this one also looks rather low. Okay, this one's 14 pixels. But how it's actually determined is actually 1/4 of the image's height, or in this case 11. So the minimum I allow is 11. So that'd be basically up to here. No part of the hill, there should be no transparent part anything below that. And that's where that part comes in. Oh, not that. Wrong window. I tend to hit this and then GIMP so I can always watch the page faults and such. Or when GIMP freezes, I can always close it right away so it doesn't hog up the CPU as per the infinite loop bug. Anyway, so you remember that 1/4, right? Well, one of the factors that's included is this. Okay, you remember the 12 to 1 ratio here, right? Okay, well, you got 12 to 1 here, and then you got 4 for this, but that's only 48. Where is this coming from then? Well, 48 times 48, or something around that. Or actually, it's based on this here. So it's 48 times 44, and that's basically what this is. And if you want to know the whole formula, that's this right here. Notice the divide by 4 there. And this difference here. Yep, that's how I determine the difference determine the spacing of the gap. Now if let's say I change this to 46. Hey, that's different. Okay, now if this is 45, it jumped huge difference. And if I went with this, tiny. Now you see, starting to see where that comes from. Z. Just need to get the original. Yep, that looks right.